In this video, we're going to be looking at analyzing hypotheses. So first, just for a definition, a hypothesis is a claim about a characteristic of a population. So here's a couple of examples. First, a drug company claims that patients using its weight loss drug lose an average of 24 pounds in the first 3 months. That is a hypothesis. Another hypothesis we have is a medical researcher claims that the proportion of U.S. adults living with one or more chronic conditions is 45%. So they're making a claim about a characteristic. The first one was claiming that the characteristic here is that they lose an average of 24 pounds in the first 3 months. The second one was claiming that the characteristic of the proportion is 45%. And so to analyze a hypothesis, you need to distinguish between whether the results that can easily occur by chance and results that are highly unlikely to occur by chance. And we can do this by using a simulation. If the results are highly unlikely to occur, the hypothesis is probably false. On the flip side of that, if the results are highly likely to occur, then the hypothesis is probably true. So let's look at an example. So number 1 says you roll a 6-sided die 5 times and do not get an even number. The probability of this happening is, 1/2 to the 5th power, and this is about 3%. So you suspect this die favors odd numbers. The die maker claims the die does not favor odd numbers or even numbers. So that is the hypothesis of the die maker claiming that the die does not favor either or. And so you simulate rolling the die 50 times by repeatedly drawing 200 random samples of size 50 from a population of 50% ones and 50% zeros. Let the population of ones represent the event of rolling an odd number. The histogram shows the results. What should you conclude when you roll the actual die 50 times? And let's say we first get 26 odd numbers. So getting 26 odd numbers in 50 rolls corresponds to the proportion of 26 over 50, which is equal to 0.52. And so we see in our histogram here, 0.52, that's between the 50 and the 54. And I see that relative frequency here is 0.6. So that's relative frequency. .16 on our simulation. And so in this simulation, this result had that relative frequency 0.16. And in fact, most of the results are close to 0.5. I see in this histogram that the bars are higher around this 0.5. And so we see that the result can easily occur by chance. So that means that we can conclude the maker's claim is most likely true. And again, that is because this result can easily occur by chance. This 0.52, I see that actually happened the most in my simulation. That relative frequency of it happening was at the highest. And so that means that this is most likely actually fair. Okay, now let's look at for getting 35 odd numbers. So looking at that proportion, 35 divided by 50, I get 0.70. And so I see for 0.70, that actually never occurred in our simulation. They didn't have any results there. So I can say this result did not occur. And so because getting 35 odd numbers is highly unlikely to occur by chance, so we can say the result is highly unlikely to occur by chance. So we can conclude the maker's claim is most likely false. So when analyzing hypotheses, there are conclusions that may or may not be correct. And then, so this table summarizes the incorrect and correct decisions that could be made about a hypothesis. So first decision, you decide the hypothesis is true, and the hypothesis is true. That's a correct decision. Sometimes you may decide the hypothesis is true when it's actually false, so that's an incorrect decision. On the flip side of that, you may decide the hypothesis is false when it's actually true, so that's incorrect. And you decide that hypothesis is false when it actually is false, and so that is a correct decision.